Greetings, Algebra 2 people. Today we're going to learn about solving exponential and logarithmic equations, okay? We've learned what they look like. We've learned the rules we can use to manipulate them in different ways, but now we're actually going to go through and look at using those rules in part as well as some new approaches, and we're going to learn how to solve these. So the first thing we're going to do is to solve some exponential problems. For example, on page 473 in your textbook, this is where your homework comes from. Let's work some problems from your homework together to get you a good start. And on page 473, it asks us to solve a problem that looks like this. 2 to the x equals 8. This is problem number 7. And the first way that we're going to look at these is to think about the bases as maybe being the same. In other words, the base here is 2. So can I look at 8 and rewrite 8 as a base of 2 raised to some power? And hopefully we remember that if we take 2 to the third power, we'll get 8. Okay? So I'm just rewriting the number using the base from the other side of the equation. The base here was 2, so I want to rewrite 8 as 2 raised to some power. And I know that if I raise 2 to the third power, I get 8. So I'm just rewriting 8 as a power. Now, this should be pretty obvious as to what x is. If 2 to the x is equal to 2 to the third, then I think x probably equals 3. So we have that solved. That's our solution. Okay? We're going to do the same thing in a slightly more complex problem. So let's jump down and look at number 11. Again, we're still on page 473. And we have to think of 32 as a power of 2, right? Because the base here is 2. So I want to rewrite the number 32 as a power of 2. Now, maybe we don't know what 32 is. We can use our calculator and guess and check a little bit if you want to. Let's just maybe say, I wonder what 2 to the fourth is. Well, 2 to the fourth is 16. So I didn't get 32. Maybe have to use a higher power. 2 to the fifth, maybe? Yeah, 2 to the fifth gives us 32. So knowing that 2 to the fifth is 32, I'm going to rewrite my 32 as 2 to the fifth power. Now notice that if 2 to the 5x plus 1 is the same as 2 to the fifth, that just like we did over here, x would be equal to 3. So I'm going to set these exponents equal to each other. I don't have to worry about the bases anymore because I know that the exponents are going to be the same. So I'm going to write 5x plus 1 is equal to 5. The exponent 5x plus 1 has to be the same as the exponent here, 5. So I set them equal, and we can just solve this equation. We can subtract 1 from both sides, and we'll get 5x is equal to 4. Then we can divide both sides by 5, and we'll get x is equal to 4/5. And that's our solution. Okay? So this first method was that we can write the number as a power using the same base as we have on the other side of the equal sign. Okay? Let's move on and do the next type. This looks very similar. However, I can't think of how to write 3 as a power of 2. Earlier up here, I knew that 8 could be represented by 2 raised to a power. But over here on 15, I don't know how to write 3 as a power of 2. So we're going to do things a little differently. And it's weird, but when we start off with an exponential, we're going to turn it into a logarithmic. That's how we solve exponential problems. So what we do here is we can say that the log of 2 to the x is equal to the log of 3. All I did was take the log of both sides. Okay? And once we have it written this way, we can use our power rule to put the x in front. So I'm going to write this as x logs of 2 is equal to the log of 3. All right? Now, how can I get my x by itself? Well, I could divide both sides by the log of 2. Right? And over on this side, your logs are going to cancel. The log of 2 over the log of 2 cancels. And I'm just left with x. And on the other side, I have the log of 3 over the log of 2. We can do that on our calculator. We can do the log of 3 divided by the log of 2. Okay? And that tells me that it's approximately 1.58. So we can write approximately 1.58. All right. I was just looking to see what your book is expecting us to do. Find number 15. They wrote it out to more decimal places. They put 1.5850 because I guess they're asking us to round to the nearest 10,000. So I guess we should have went out one more spot. 50. 1.5850. Go out that far, I guess. All right. Let's do another one like number 19. See how this works. When it's an exponential problem, okay, we can solve it by taking the log of both sides. So we're going to say, well, let's do the log of 9 to the 2y is equal to the log of 66. Okay? We just took the log of both things. How do we solve this? Well, you can put the exponent again in front. So we're going to write 2y logs of 9 is equal to the log of 66. What would we need to do from here? In this case, we can divide by 2 logs of 9 on both sides. And that'll leave us with our y, because the 2's are going to cancel, the logs of 9 are going to cancel, and that leaves us with y on the left-hand side. And on the other side, we need to actually do that. So we'll take the log of 66 and divide that by, and I'm going to put this in parentheses to make sure that everything works out right, 2 logs of 9. That tells me it's approximately 0.953. How far do we need to go? We'll stop at 4. 0.9534. Okay. Ta-da. So the second method that we have is that we take the log of both sides. And this happens when we have an exponential problem that we can't rewrite the base for, right? Let's move on to the third way to solve. And we're going to start off with problem number 32. When we do this, we're going to use our fishhook method. Okay. This says log, and when there's no base given, we understand that it's log base 10, right? And remember the fishhook? We can take the base, raise it to the number over here as a power, and what we get from that is this. So if we did that, we're going to get 10 to the negative 1 is equal to 2x. And remember what 10 to the negative 1 means. Let's refresh our memory. If we did x to the negative 1, we'd get 1 over x, right? And again, if we did like x to the negative 2, we'd get 1 over x squared, and so on and so forth. So what would it be if we had 10 to the negative 1? 10 to the negative 1 is 1/10, and that's equal to your 2x. How do you get x by itself? Divide both sides by 2 or multiply by 1/2, however you want to look at it. So we get 1/20 is equal to our x. Okay? I think your book probably leaves these in decimals. So if you want to write that as 0.05, you can. Because 1 divided by 20 is 0.05. Groovy? I like fractions, but your book is your book. Let's do 36 because this is even more fun. Okay? Now, when we did the fish hook over here, notice that the log was all by itself. It was the log of 2x. There wasn't anything else there. We were taking the log of 2x. But over here, we have the log of 6x, and then we're subtracting 3, and we get negative 4. So before we begin, we need to get the log by itself. Okay. So one of the teachers from a long time ago used to say, to solve these, you have to clear the bushes away from your logs and then go fishing. Okay. So we got to clear the bushes away, and right here, this is something that he might say is a bush. It's a number that's over here that we have to do an operation with the log from. So we're going to clear this away, and we'll add 3 to both sides to do that. Okay, that's going to leave us with the log of 6x is equal to a negative 1. Now, once we've cleared away the bushes from the logs, we can go fishing. What's the base here? The base, again, is 10 because they didn't say what it was. And we go fishing. 10 to the negative 1 is equal to 6x. So once again, we know 10 to the negative 1 is 1/10. Actually, maybe we'll go, since your book is happy using decimals, maybe we'll write it as 1/10. Oop. Hopefully you all know that 1/10 is 0.1. Is equal to your 6x, right? And then we can divide both sides by 6. And we'll get 0.1 divided by 6 gives us 0.016 repeating. So there we go. Problem is 36 in your book. Yeah, they rounded off to 0.0167. They didn't say it was repeating, and that's okay. They're rounding eventually. All right, so 3 methods for solving logs. 1, rewrite the base. Kick out the base, all right? 2, if it's an exponential function, take the log of both sides. 3, if it's a logarithmic equation, clear the logs and go fishing, okay? That's how we do these problems. Your homework assignment is, let's find out what your homework assignment is. Let's go to the plan book. Homework assignment should be on page 473. You're doing 7 through 22, which we've already done some of, and 32 through 45, which we've also done some of. All right. So homework assignment is on page 473, 7 through 22, 32 through 45. Have fun, good luck, and hopefully we'll see you real soon. Bye-bye.